Now the hardware I am showing with the help of ADC channel, right? The first we have set for 20 volts here to overcome the problem of ADC value, ADC sensor. So and the output voltage now I set to 15 volts through using this rheostat, and this is the high frequency multimeter, and the current I am showing presently 0.7 amps, 77 amps, right? And this is a duty cycle 77%. Now, so now I have written the calculation clearly here. You can see for already previously I have explained for 3.3 volts, 15 volts. 3.3 volts is the output of ADC channel. If it is 3.3 volts, then actual voltage of the load voltage of rheostat is 15 volts. So now this is 15 volts. So practically we are getting a 14.44 volts of with the multimeter, and you can see the duty cycle is almost equivalent to 80%. In the CRO we are getting 77% of duty cycle for this 15 volts. And you can see how you can calculate the duty cycle is, for example, we are having here 8000 divided by, inside I have used the timer period. What is the timer period value? I have used the 10,000. So I will show it in 10,000. So therefore 8,000 divided by 10,000, which is almost equivalent to 80%. Practically we are getting a 77%. Practically we are getting a 77%. Now I am changing the load voltage, reference voltage. Now the output voltage I am changing it to 10 volts. So I am giving 2200. So which is equivalent to 10 volts. 2200 volts, which is equal to 2.2 volts of ADC channel, which is equal to 10 volts. Now I need to get an output voltage of 10 volts. Now practically previous values 15 volts, like the almost practical value 14.44. Now it has to change to 10 volts like that. So here you can see now it is changed. So now the voltage, immediately the voltage is reached to 10 volts. Immediately the voltage is reached to 10 volts. Now the duty cycle percentage, you can see it is reduced to 57%. So now here the calculation, you can see whatever the reference value we are keeping 2200, which is almost we are reaching the same value, and the duty cycle percentage I already explained. Whatever the value we are getting here divided by 10,000, if you get the same almost duty cycle, you should get over there. Now last calculation I want to go for this one, that means 1500 volts, which is equal to 1.5 volts of ADC sensor, which is equal to 7.8 volts.
Sir.
We are going for the 1500 volts, which is equal to 1.5 volts of ADC channel, which is equal to 7.5 volts of your rheostat. Now you can see already previous value. What is the value? 10.48. We are getting almost. Actually, we need to get 10, but due to some slight control, we are getting 10.48. Now you can see 7.0 volts we have to get. So for that we have to change 1500. Yeah. Now whenever you are changing 1500, immediately it has to change, your voltmeter has to change 7.8 volts. Now I am changing 1500. So now I am changing 1500. Immediately you can observe the voltmeter. So it has to change. It should change to 7.5 volts. So I am applying. You please observe. So you can see now it has changed to value of 7.36. Now come here and observe the duty cycle. So based on the value you are getting, your actual value is also going to reach the closed loop, and this is your duty cycle percentage, 43.85 or 44 like that. So you can see almost near to that one. So 41 or 42 because of some slight fluctuation. So we are getting that one. So this is about your closed loop. That means whatever the reference value you are changing here, it should appear as actual voltage. So based on that one, your PWM signal duty cycle has to change. Now lastly, I am going to change the rheostat. That means load current. If the load current change, lastly, now I am changing the rheostat value, which will change the current. Now, but your output voltage should equal to 7. So now the last concept is, if you change the current also, your output voltage should remains almost same, right? So now I am changing the load current value. Now the current multimeter, it is almost equivalent to some 0.3 amperes. So like that. So now I am changing the current, you can observe, and output voltage also, it will remain the same. So you can see. So you can see the output voltage and current, both are, current is increasing but the output voltage remains same.
పర్లేదు పెంచండి.
So now for our 1500 value of ADC reference voltage, now already 7.4 something and current is some 7 point something like that. Now you can see if the current is increases, your voltage is almost constant. Your voltage is almost constant. So that is the main advantage of using this PI controller. Now you can see again we are using 1500, even changing the load voltage also no problem. Even changing the load current also no problem. Whatever 1500 we need to get some 7.4 like that. We are getting the multimeter, with multimeter you are getting the almost same value with high currents also. So in this way we are controlling the closed loop control.